I'll keep the introduction part short. My name is Seppo Tarvanen and I work here. Today I will talk to you about how to effectively test your software in a web application context. I'll cover a few basic concepts, what could be used as a foundation for your test suite, the definitions of each level of testing, how to benefit from them all, and also my personal preferences, how to choose the correct type of test for your feature under development. And there's a hint in the title. Testing pyramid as a concept is probably the most well-known when it comes to determine how much testing we should have on each level. In the pyramid, the end-to-end tests are at the top, integration tests in the middle, and unit tests at the ground level. This concept represents the magnitude, how much testing we should have on each level. So on paper, when we follow this model, we should end up with a pretty decent test suite. A lot of unit tests, quite nice set of integration tests, and few end-to-end tests. There are also other models, even more wild than this, but this is also something that is referred sometimes testing trophy, which states that we should mainly use integration tests. This model is usually or initially used in front-end context, but like everything else, this is also adapted in the places where it wasn't originally designed. According to the author, the downside of unit tests is that they need to be changed when implementation changes. But that is mainly due to how the author defines what a unit test is. This model also introduces static tests, which covers tool usage like linting. But I argue that any of these models, no matter what they are, we shouldn't be too interested in any of them. The model alone doesn't help us how to test. It does not give us the answers, what type of things we should be testing in each level. The main point of my whole talk today is that we should focus our testing to the places where it hurts the most. For example, if the feature your team is working contains a lot of domain logic that you need to implement yourself, you should do as much as unit testing you possibly can. You should be able to isolate that logic from the outside world, meaning external services, and test it separately. On the other hand, if the feature relies heavily, for example, into database logic, meaning it sorts, filters, uses pagination, you should cover that feature mainly using integration tests. But first of all, let's get on track with a few key concepts here, because everywhere you look, the definitions of integration tests and unit tests vary. And that is the reason why every time we talk about them, we need to define what they actually are. And you might disagree with the definitions I'll present here, and that is totally fine. It just means that I will also disagree with yours. So, what do I mean by unit test in this talk? In the simplicity, it is a test that does not require any third-party services, databases, network traffic, or anything else around it. Plain and simple runnable code. It does not matter to me how many classes or functions a single unit test cover. I only care that my unit tests test the code that I have written myself or my team has written. This definition I use here is sometimes referred as sociable unit test, but I don't really make that difference since pretty much all my unit tests are extremely social. The integration tests. That definition is also vague in our field, but here it refers to a test that requires, for example, starting the application. And as the name suggests, it tests integrations, but not necessarily the functionality of the third-party service behind the integration. In my integration tests, I use the real implementations when I can host the integrated service, or it is some other way in my own control. For example, I'm free to use real database in my tests since I can fire up a new database for my tests every time I run them. End-to-end tests might be the one that we actually have an agreement in our field. But just to make my definitions complete here, I mean tests that go through all the application layers, including UI. They are testing the software the same way the user is using the application. Keywords here could be Cypress, Playwright, Selenium, and tools like that. But in this talk, I will not be concentrating on end-to-end tests. That is not my field of expertise. But now that we are all on the same page with the definitions and we all agree with them, how can we choose the correct level of testing? I have a small imaginary sample application so that we can make examples in a meaningful way. I have this app called Booklane that is an internal library application used for companies. With the application, users can add and remove copies of the book, borrow and return them, and the data of the books is stored by using the ESBN number. ESBN number is given to an external service which fetches the book information and stores it in the application's own database. When user adds books, they need to specify the location where they are adding the book and also the quantity of the copies, how many of them they are adding. And naturally, user may also search for some new reads and see if they are available or not. So quite simple application. Add and remove copies. And the book information is fetched from an external ESPN service, and the details are saved in our own repository. And we can also search the books if we want to find something interesting to read. But let's concentrate first on the feature how to borrow copies using the application. The information flow for this use case is the following. First, client sends request to the server containing the ID of the copy and also the user token. Server validates that the user is authenticated and finds the copy entity from the repository using the ID. And if the book is available, that copy is set as borrowed by the user who made the request, and the copy is saved to a repository with the updated properties if the actual borrow event happened. If it's not available, then user can't naturally borrow that copy. And then server finds the book details, which are stored in our own repository, and sends the response object with book details and also this borrow event information. Things that we believe that are interesting to the client side. So, when to use unit testing? In this feature, does it hurt the most inside the domain logic? Without thinking too much in which level we should be testing, we can first think what we can even test in this scenario. We could test starting from the top left corner. We could test that if a user can successfully borrow a copy. So if the copy is available, then there's no problem. User can have it. In the second and the third example here, the copy is already borrowed, so the borrow event will fail. And in the fourth one, the copy doesn't even exist with that ID, so the whole process fails. So let's take a quick look at the implementation here. First of all, in that method, we pass the authenticated user and the copy request object. We find that copy using the ID, and then in the copy entity object, we call a method called borrow and pass in the user ID. It will return whether that event was successful or not. And then we get the details from the book repository, and if the event was successful earlier, we can update the copy. And at the end, we can return interesting details to the client. And the actual logic for borrowing the copy happens inside the copy entity here. So, does it hurt the most inside the domain logic? Yes. The main activity is inside this entity object. Everything else around this is just fetching things with single property or saving the whole thing. But which of these parts we can test using unit test? However, we have these external services like copy repository and book repository, which are interfaces to database. Depending on our testing strategy, we can either test first of these three with unit tests if we just test against the entity object, or all of them if we allow us to use test doubles. Personally, I'm not too afraid of test doubles, although I know that they adapt to maintainability. However, when we keep our classes small and divide our actions by their use cases, we usually have only few dependencies we even need to fake or stub. Additionally, we may use the same fakes across our tests. And in case we allow ourselves to use those test doubles, we can test this feature the following way. We can create the borrow copy request, pass it to a use case, and also pass this authenticated user along with it, and simply at the end assert that we have the title that we are expecting or the subtitle we are expecting and whether the event was successful or not. If we wouldn't be using test doubles, we could only test this if the event was successful. And I mentioned earlier that we should be able to isolate our domain logic from the infrastructure code, and this uh, mm, test setup actually shows us pretty much the way how we can do that, how we can keep our domain separate from the infrastructure. We focus our testing here in copy circulation, where we pass a few simple implementations of this copy repository and book repository. And also those same fakes we pass into inventory object. These fakes implement the same interfaces than the real objects, so we can simply pass them to the use case objects. And just a side note, when I implemented this, I implemented the fake objects easily using ChatGPT. I gave the interface description and just asked that create me a fake using hash maps, and it worked out great. And if for some reason we have problems isolating our domain from the infrastructure, it is usually due to a poor design. And to be a bit more accurate, that poor design is usually because of our classes have poor separation of concerns. We could do everything related to copies inside the copy circulation, including the whole inventory logic. After all, that inventory also handles the exact same entities than copy circulation. But the reason we don't want to do that is that we want our application to be vertically sliced. And when we do that, we tend to have fewer dependencies, meaning we don't need to mock or stop or fake a million different services in order to write a simple unit test. And we also need to watch constantly our solution. For example, in the future, we could have separate use cases for borrowing copies and returning copies. For example, if for some reason in the future borrow copy would need some other dependencies that returning copies doesn't need, or other way around. But in that situation, we should split that functionality into two. And it's not the testing that is hard. It is because the mess we sometimes make with the implementation that will eventually make testing practically impossible. For example, creating huge guard classes which holds everything. It just makes testing tedious thing to do, and I think that's one of the main reasons why some developers skip unit testing. If we don't know how to write code that is testable, we simply don't want to write tests either. But that example was suitable for unit testing. Let's next go further to see integration tests, and we'll have also a feature prepared here for that. This feature is about how we shared copies from our repositories. So when we want to find something interesting to read, a client sends query object to the server containing some properties we want to use when we filter that data. For example, location, the title or part of the title with wildcards even. Maybe when the the book was published, or the time frame in between. And how this use case goes on. The user is authenticated, and that is checked in the server. Server creates the query and passes into a repository, and simply finds the copies matching for that query. And in the end, server sends the response of the search result containing the properties that are interesting to the client. So in this example, does it hurt the most at the boundaries of our application? I'd say yes. I cannot think better use case for heavy integration testing, and it would be maybe a bit insane to try to test things like this using unit tests. We would need to fake out the behavior of a database by ourselves, and every time we add some new properties for the query, our fakes would become even more complex. And fakes should not be complex. A large language model should be able to implement them without any issues. But even though we could outsource the implementation of the fakes to the large language models, that wouldn't be the worst part. Would be that it wouldn't even test anything. It will only test whether our fakes are implemented correctly or not. And that is just waste of time. The domain layer in this feature is so thin that we don't even need a separate use case layer for this one. We simply take parameters, location, title, published after, published before, pass it into a copies query constructor, and pass that object to query copies function inside search copies repository, which constructs an SQL clause and executes it. And how do we test these? I think it's most helpful to write integration tests against the APIs. That way we'll cover all the layers of our backend. And when I have some external dependencies that I don't host myself or I don't have control on, I will simply mock those out. However, like said before, database is something that I can host, so I'm free to use real deal here. So I can bit explain what happens here. So we simply make a REST call here. We pass in query as a query parameters. We pass title and location, and at the end we just expect that we have correct information that we have created in the first function where we call create test data. But as you can see, these integration tests can also be made quite readable. So we rely heavily on integration testing when we own or host those boundaries. And of course, if the feature is combination of heavy domain logic and also logic at the edges. We could cover everything we can using unit tests and let integration tests handle those boundaries. Although that also depends. If that extensive integration tests already cover the domain logic, then unit testing might not be necessary here anymore. You don't, and we don't have to test everything twice just because some model expects us to do. So additionally to where it hurts, I usually write integration tests against each points just to make sure that they work. And to be precise, this authentication part in my examples, we can't even test using unit tests, so integration tests are valid there also. And even though the unit tests will cover the happy path, I'll usually add integration tests that also test that most obvious path. And when I do that, I am aware that I have the same test then practically at two different layers. But I don't mind. I don't want to remove that test from my unit test class because I have found it a bit odd if that test class doesn't have the most obvious test in place. So the last one, end-to-end testing. I'll just go through this quite quickly. I would say that these should be used sparingly. If the user journey is important, we should consider writing end-to-end test against it. And especially if end-to-end test works as a quality gate for production, or is integrated into our deployment pipeline, I think it's important to keep them fast. So basically, if you can keep them fast and reliable, they can be used as a good tool. And what this talk didn't cover are unit and component tests in the client side. With those tests, you don't have to rely solely on end-to-end tests when you're trying to test your client-side logic. But the same thing, however, applies to those tests. If the document object model is important in the client side, you can test against that. But if the logic is complex and the actual UI layer is simple, we could merely test the behavior of the component, not its UI. Just a brief wrap-up. Different models like test pyramid won't necessarily help us creating the best possible test suite. We always need to think our problem at hand. And secondly, when we discuss about software testing, we should first be clear with our definitions. They are not the same for everyone. And last, we should choose the level of testing based on how we are about to implement that feature. If there's a lot of domain logic, write unit tests, and if the behavior takes place in the boundaries and we can own or host them, we should write integration tests. Thank you all for watching. We'll stop the recording now, and if you have any questions, comments, feel free to share them. Thank you.